Hey everybody, this is Duke with a video on our initial Betaflight configuration for the FPV class. I'm going to try to make this video quick. It's going to be a little bit longer. Of course, we got a lot to do in the video, but I'll try to make it as quick as I can. We're going to go through this setup here and configuring different things for our copter to be able to have it do its test hover appropriately and work and be how it's supposed to be. Get ready to fly. Okay. So we're going to walk through these steps one by one using the Betaflight configurator on our computer, as well as our finished or physically finished aircraft. So your aircraft should be all soldered up and passed off and stuff that way, and now you're working on the software. So over here on the bench, I have a couple things. I have the flight controller that you guys are using, but it's not a spare one, so I can't solder everything to it right now. And then I have a bench flight controller from a drone that crashed and stuff. And so I'll be going back and forth a little bit between these two to show you like what it will look like with your flight controller. But then when I connect up my transmitter and stuff, it'll be connected to the bench flight controller that's already got a receiver and GPS and all that good stuff. So a little bit back and forth, but I'll try to make it as clean as possible so that it looks like it would look for you when you actually do this with your flight controller. All right, well, let's jump into it. Okay, go over here to the Betaflight configurator. First thing I'm going to do is plug in my F405 Mini or plug in my aircraft with USB. No battery, no props. Okay, we'll not need props for any part of this assignment, but we'll need a battery later on. Okay, so once I plug this in, I'm going to go ahead and look for my USB device. There it is, COM5. I'm going to go ahead and connect over here. And we did this before in class. You see your drone moving around, and as you move around, it's cool to see that model move and everything. But I noticed a lot of the flight controllers that had been distributed in class are on older version of firmware. So we're going to need to update our firmware before we do anything else and get that all set up. The latest version at the time of making this video is 4.5.2, but a lot of the flight controllers that I saw in class, as you guys went through them, were 4.4.2. So we want to fix that. We're going to go over here to the CLI tab, and we're going to type BL, and press enter. That will put the flight controller into bootloader mode. So you'll see that change up here to say bootloader. Okay. You then click on update firmware instead of connect. So update firmware at this point. And we're going to go down here to the section here. You can choose a board. We're going to type in SpeedyB F405, and it's the Mini. If you have the Mini, or if you have the all-in-one, then it's the all-in-one, of course. Different boards. Here's lots of different options. We're going to say Mini. Okay, and then it says 4.5.2. That's the latest version of Betaflight as of this video. You can have full chip erase selected. I don't remember what happens if you turn expert mode off. You just have expert mode turned on. So I guess, oops, cleared all my stuff there. You can just use that as you see fit. And then we'll go ahead over here to the right side section of the firmware flasher tab. Radio protocol, CRSF, is what we use for ExpressLRS receivers, which most of you have. If you have something else, you can find that protocol here. For example, S-Bus, you want to make sure you select S-Bus. Okay. I'm going to set this up with CRSF though. And we see the telemetry protocol is automatically included. OSD protocol, we want to use analog if you're flying analog, which I believe everyone in class is this semester. And motor protocol D-Shot is perfectly fine. So there's our options there. Other options, you can click down over here to the right and get a drop down if you want. You can see all the different options for kind of specific things that you might want to include in the firmware. But the defaults here, Acro Trainer, GPS, LED strip, Pin IO, VTX, that works great. Might be a little bit extra stuff we don't need. For example, we don't have any LEDs, but if you want to add this stuff later on, you have to reflash the firmware. So doesn't mean include everything by default, but these defaults are fine. So we'll leave those alone there. Custom defines, leave that blank. And then scroll down here and say load firmware online. Okay. There we go. Success, it loaded. And now this button, flash firmware, is able to be clicked on. I'm not going to flash the firmware right now because I've already done that with this flight controller, but you would hit that button, watch the progress bar go across here and everything, and then it will say programming successful at the end, and your flight controller will reboot, and then you'll be able to connect to it normally over here. Okay, so I'm going to go ahead and reboot my flight controller manually by just power cycling it. And we'll connect up. Oops. Did it not, just a second here, I think it didn't reboot properly. And what happened? Okay, minor difficulty here. Give me just a second. There we go. Guess I bumped one of the plugs. Okay, so then we'll hit connect. And there we go. Once we get it back into the main page here, we should see Betaflight firmware 4.5.2, SpeedyBF 405 Mini up here in the upper left-hand corner. That's great. That means that you have used the web version of the configurator and updated your flight controller to include these things. And the web version of the configurator is one we already tried in class, but again, I would recommend using that version, the app.betaflight.com configurator. Okay, awesome. So first two steps are done here. We're going to now correctly calibrate and orient our accelerometer / gyro. Okay, and we'll do that by going over here to the Calibrate Accelerometer button. At this point, you want to have your drone flat on the table, facing away from you, so facing, towards the top or front of your desk or whatever you're working on. Just have it nice and flat, and you're going to hit Calibrate Accelerometer. So to calibrate, and at this point, also, if you have the aircraft facing away from you, then you can reset the z-axis, and now it should, appear just as it does in real life as you move it forward and back and left and right and upside down and all that good stuff. So that's all available right there. Okay, great. In the configuration tab, we will double check, but by default, these settings should be what you want. The board alignment and gyro alignment can be used to help the software know which direction your drone is facing. If you had to mount your flight controller upside down or rotate 90 degrees or something from what the default would typically be. But we don't need to change anything here in our setup as long as you mounted it just normally on your frame. Okay, there's those two. Okay, now we're going to configure the ports for our RX and VTX. Okay, so when we look at our wiring diagram here of the flight controller, our receiver up here, ExpressLRS, is going down here to R2 and T2 in terms of the RX and TX pads. And so the big thing I want to pay attention to there is the number R2 and T2. And that means that the receiver is connected to UART number 2. And then we go down here to the bottom, and our video transmitter is connected via this IRC line to T1 or UART number 1. Okay, so receivers on UART number 2 and VTX is on UART number 1. So if we go over into Betaflight, we're going to go to the Ports tab, and we see these are already set up from earlier, but we have our UART number 2, serial RX is turned on. That's our receiver. And then for UART number 1, we leave this sliders alone. We go all the way over to the right-hand side, and you select TBS Smart Audio, since that's the video transmitter type that you have in class, which is slightly different than the diagram on the SpeedyBee website. So Smart Audio here on UART 1, receiver on UART 2. These are the ones you want to leave alone. This is our USB connection. Don't touch that one. And then UART 4, I believe, should be the Bluetooth connection you can do via the app to your flight controller. We'll talk about that later in class. So once you have it set as you see here, you can go ahead and say save and reboot. It will reboot, and if you have auto connect checked, it will auto connect. And go back to the ports tab and make sure everything's looking good there. These are basically the different ways you can connect external devices to your flight controller. So you can see we still have UART 3 available, as well as 5 and 6 if you wanted to add other things. We're going to add the GPS later on in this video to one of these UARTs as well. Okay, let's go back over here. All right. Now we need to correctly set up our receiver in the receiver tab and make sure it's working and the sliders move on stick movement. Okay, I'll show you the sliders in a moment with the bench flight controller, but for now we'll go ahead and go into the receiver tab. You want to make sure that the receiver options here are set appropriately. So serial via UART is how our receiver is connected. That's perfect. And we have CRSF because in my case I'm using ExpressLRS as an example. If you had SBus, for example, then you want to have SBus selected. You can see I can't pick SBus on mine because I didn't build that option into the firmware. That's why it's important to pick the options ahead of time so you don't have things come up later. You got to reflash the flight controller. Down here we want to make sure telemetry is turned on, at least for CRSF, and that's really all we need to do for this page. For right now, we'll show you the sliders moving around later on the other flight controller. So you can say save, and that works there, and saves it like so. Okay. If you're using ExpressLRS, you won't be able to get the sliders to move and stuff until you bind your transmitter and receiver, or really any transmitter receiver you have to bind before having it work. So I'll talk about that more in a second, but here is a link on how to do some of those ExpressLRS binding processes. If you have a different type of receiver, you'll need to research that or come ask me for help. I'm not going to go through binding in this video because it's kind of a separate topic in some regards. Okay, all done with 1 through 5. And now we're going to move on to number 6, set up our VTX table. Okay, and I don't know why I should have moved this out. This next point here doesn't have anything to do with VTXs, but we're going to set up our VTX here. And the way we do that is we find what's called a VTX table. So when your flight controller is connected to your VTX, it can send the VTX commands like change power level or change channels, but it can't do that appropriately unless it knows which channel you tell it corresponds to which actual frequency the video transmitter should be on. And you'll see more of what I mean in just a second. But I'll have a link right here where these asterisks are to this website. Okay, and this is Rush FPV's website. They have a VTX table download area. You click on that, and we'll get the VTX table for our video transmitter. We have the Race 2, and we want the 48 channel version here. So Rush Race 2 48 channel. We'll download that to our computer. And it just takes a second. And once it's downloaded, we'll go over into Betaflight. I'll go down to the Video Transmitter tab here and open this up. Now yours may look different because I already have the VTX table installed on mine. Yours will be blank here. Okay. What you'll do is you go to Load from File, and you'll find that JSON file you just downloaded. Okay. And it will load in all of this stuff down here as well as the power levels. So what that does is it tells your flight controller, hey, flight controller, when I say go to, let's say, channel B6, we go B6, you tell the video transmitter to go to this frequency. Okay, it's a lookup table basically, and so that corresponds there. And then the flight controller knows what to tell the video transmitter to do, and it does it. And great, now it's on the right channel. And then down here below, we also have power levels. So our video transmitters go from 25 to 400 milliwatts. And so you can change power levels from your flight controller as well as you give that command to tell it to do that. And it will know what to go to. We'll fly at 25 milliwatts when we fly together, but if you're flying by yourself, you may want to turn up the power a little bit, get a little bit more range out of your video transmitter. Once you've loaded that file in from file, then you can then hit save. And it will save all this to the flight controller, so that's perfect. All right, back to our list here. Okay, next one here. Again, this is supposed to be a separate line. I need to fix that in the formatting. I apologize. If you're using ExpressLRS, we're going to apply a link preset for ExpressLRS. So let's go over to Betaflight and go to the Presets tab up here. The default that comes on most RadioMaster ExpressLRS internal module radios, which is what most of you have, I believe is 250 Hertz. So if we type in ELRS here, we have different options for the preset. But if you're on 250, then you would click on 250. If you're on a different one, click on a different one. They all have similar things here in terms of the drop down. So you go through this drop down and select what applies to you. In the case of our class, we would pick freestyle, serial, receiver connection. I prefer single cell values readings. That's up to you a little bit more there if you want the value of the voltage for the whole battery pack or just the single cells. And then we aren't using cinematic rates, so I wouldn't pick that one. Once you've selected those things, you can say pick, and then you can say save and reboot, and it will apply those settings and then reboot the flight controller. Kind of like a package of settings all together with the preset. I'm going to reconnect here. Okay. And that's our preset here for ExpressLRS. If you're not using ExpressLRS, don't worry about doing that. You don't need to do that preset. Okay, next up we have our motor direction, position, and ESC protocol type, including turn on BD shot. This one is where you will need a battery for your drone. Do not have the props installed. We don't need props, but we need a battery for this step. Okay, and we're going to try to do this step a little bit quickly because we don't want our video transmitter to sit there and overheat. If you have like a little desk fan or something you can blow at the video transmitter while it's sitting there, that would be a great idea. If not, then maybe watch this section first, you know what I'm doing, and then go ahead and do it yourself instead of doing it as I'm explaining. So for this, we're going to go over to our motor tab. Oops. Okay, and then we have our top box here, so I'm getting some artifacts on my screen. I don't know if you guys can see that or not, but I'm going to reload the web page real quick. Sorry, it's drawn all over the screen. That's weird. I don't know if you guys can even see it, so I probably look like a crazy person, but there we go, that's better. Okay, so over here in the Motors tab, we have our Quad X selected. That's the type of quad we're building, an X-type frame, and it's a quad. It's not like a tricopter or an octocopter or something else, so that's fine. You can see I have my motor direction reversed selected here. Yours by default will be in this orientation, so not reversed. And you can see here the propeller directions show, well, they change depending on whether your motor direction is reversed or not. So by default, it's what's called props in. The props rotate in toward the nose and in towards the tail. I prefer flying with props reversed, motor direction reversed, and so props out is going to go out away from the nose and out away from the tail. Once you've picked what direction you want to fly, you can look up pros and cons of each. A lot of people fly props out because it flings debris like grass and stuff away from the camera. The propellers do, so the camera can stay a little bit cleaner. That's one advantage. And so once you've selected that, you'll then hit save and reboot, and then these buttons down here will be available for you to click on. Okay, so what we're doing here is we're going to go ahead and help the flight controller know which motor is in which physical position and what direction they're spinning. So one by one, we're going to go ahead and say reorder motors. We don't have any propellers installed, but we do have a battery plugged in. Okay, we're going to say start, and then a motor should start spinning on your quad on the bench. Okay, I don't have a quad with motors hooked up right now to show you that, but you'll have one start spinning, and whatever one's spinning, you're going to click on that quad, or that motor, sorry. The quad's facing away from you, so let's say the front right motor starts spinning on the bench. You say, oh, front right, perfect. And then the back left starts spinning. You say, oh, back left. And then front left. Okay, now back right. Perfect. And once you finish, you say save. Excellent. It's going to reboot the flight controller, and we'll go back into the Motors tab. Okay, so now we just told the flight controller which motors are where, so in terms of these like numbers, 1, 2, 3, 4 kind of thing. And then we'll do the motor direction. Okay, we're going to, again, no props installed, but batteries plugged in. And we're going to use the wizard. And then this one here, we're looking for the direction. So in this case, motor 2 should be spinning counterclockwise. Or sorry, clockwise. Clockwise. The motor 4 should be spinning counterclockwise. Motor 3 is clockwise. Motor 1 is counterclockwise, etc. So we're going to say start spinning motors. They should all start spinning. And then you can check the spin direction with just your finger by feeling them if you want to. Or if you don't want to do that, before you start spinning the motors, you can put a little piece of tape kind of on the motor, and as it spins, you'll be able to see more easily or kind of feel the tape with your finger which way they're spinning. So however you do it, you'll start them spinning, and if any of the motors are not spinning the way that's shown in this diagram, you'll click on the number that corresponds to that motor. So let's say 4, instead of spinning counterclockwise, it's spinning clockwise. That's not correct. So I'm going to click on 4, and now it will pause, and then it will start spinning again on the table, and it will spin the other direction. So now it should be spinning correctly, because we just changed it. So change any motors that need changing. You know, say 1 and 4 needed to be swapped. Once they're all spinning the correct direction, you say great. You say stop motors, and then it saves that. You say close. Excellent. Okay, that is our motor spin direction position configuration. It's probably one of the most common things people get messed up, in addition to putting the props on wrong, that can cause the quad to kind of flip over on takeoff and get some damage. Okay, so make sure you triple check that. Here down below we have the ESC motor features. We just need to basically adjust two things here. We'll select D-Shot 300, and we'll select bidirectional D-Shot. Okay, you'll get a warning here. You say agree, and I'm going to turn it back on. And it'll say, do you agree? Yes, I agree to turn that on. It's going to adjust some filters for us, and that's fine. So I went by that a little bit fast. Let me see if I can get it to pop up again. There we go. So it says it's going to change these values, the dynamic notch filter values. That's okay. Just say agree, and we'll have this turned on. Okay, and D-Shot 300. That's all you really need to do for this page right now. The defaults are working for everything else we have set up. You'll hit save and reboot. Once you've done everything, it will save and reboot the flight controller. And at that point, your motors, direction, position, and protocol type should be working, or should be set up correctly. Okay, awesome. For these next couple steps, I'm going to need to use the other flight controller since it's got a receiver and stuff on it. So I'm going to go ahead and get that connected up instead of the F405. So let me go ahead and unplug this. Plug in the other one. All right, sorry it took me a minute there. So we have this on the bench now, plugged in here, and we're going to go through some of our transmitter receiver type stuff. So I don't know if you can see this on this one here, but I have a receiver, I have a GPS, I got a little camera over here. The video transmitter will plug in right here. I just have it unplugged right now so it doesn't overheat. Okay. And that's one thing you want to pay attention to when you're doing the motors and other things that require a battery. Try to minimize your battery on time when you're not flying so your video transmitter doesn't overheat on the bench. Mine has a nice plug so I can unplug it, but yours will be soldered. So, okay, there we go. And we're going to go ahead and go back to our Betaflight and reconnect here. Okay. And so at this point, everything's looking the same, even though I have a different flight controller connected. It's all the same, so don't worry about that. We go to our receiver tab first of all, and now we can finally see these sliders moving around as I move my sticks on my transmitter. So I'm moving my two gimbals around and getting the quad moving and flipping, and the sliders are all moving. That's the kind of confirmation there that the transmitter is talking to the receiver and the receiver is talking to the flight controller. Okay, so that's one thing there. We go to flight modes now and set up some flight modes. I'm going to turn this off for a second. There are a bunch of different flight modes here, or different things you can do. Well, they're not all flight modes, they're just like modes, I guess. Different things you can do with switches and stuff on your transmitter. Okay, and so we can see here I've set up a few different ones already. I'm going to go ahead and clear some of these out so we can, oops, X over here, clear some of these out so we can see how they get set up and go from there. So you will be met with a page like this where it's blank and you haven't set anything up yet, and that's okay. What we want to do is have a switch set up on our transmitter. Okay, you should have already done that in the process of setting up your transmitter and binding it and creating a model for your aircraft. So I'm not going to really go over that in this video. We should, at least as a minimum, have a channel 5 switch set up. Channel 5 switch set up with our transmitter. And so what that would look like, let's switch over here. My transmitter. Okay. My transmitter is connected to my receiver, and then in the model menu, if we page over till we get to mixes, you can see channel 5 is assigned to switch E or SE right here. Okay, SE is at the top. That's my arm and disarm switch. You should have done that already, and so I'm not going to show you how to do that a bunch right now, but we should have that working. And if we go page over from the main page, we have our channel monitor, and if we flip that switch, we have channel 5 goes high. Okay. Excellent. Go back here. Let's go back over to Betaflight. Okay, so what we can do now is we can go ahead to this arming mode and we can say add range. Make sure I got this. Yeah. Add range. Okay, and it says auto. And if we already have a switch set up, all we have to do is flip that switch now. And it picks up on what channel it is and everything for us. And now we can see that it's armed or disarmed. I'm going to drag the slider over here because you don't really need a 3-position switch here. We just need armed or disarmed. Okay, and now that channel on our transmitter is linked to do this action. In this case, arm the aircraft. The same thing applies for the other things we want to set up. So in this case, we want to set up angle mode as well. So I have another switch already set up on my transmitter. I'm going to hit add range and then flip that switch, whatever switch you want to use to engage angle mode. Okay, and we're going to again drag it over. Angle mode is just kind of I only have you use 2 modes in class. You can use others if you want, like horizon mode and stuff like that, but I really only have you use acro mode and angle mode in class. So now we know when we flip the switch, angle mode will be engaged. When the switch is not flipped, acro mode is engaged. Acro mode is the default mode. If you move any modes, then those engage, but once you're out of any other modes and not in a specific mode from this list, you'll be in acro mode. So angle, acro. All right, let's keep scrolling down here. We're going to set up a failsafe switch so we can test our GPS stuff a little bit later on. So another switch on my transmitter set up already. I'm going to hit add range, flip that switch. Great. So we're going to drag this over to be about halfway. Failsafe on, failsafe off. Okay, great. You can add other things like a beeper switch if you want to. Um, we will use black box in class, so you can either have that set up kind of by default to just run all the time, or you can have it on a switch. I'm going to add it on a switch right now. Okay, so I can turn it on and off. There we go. There are lots of other things in here you could do or use. One thing that we'll talk a little bit about later in class is our flip over after crash switch, which is also known as turtle mode. So again, the same process, assign a switch on your transmitter to control a channel, and then add range and flip that switch. Okay. That's all the ones we really need to start off with, are what we've set right now. So we can go up to the top now and say hide unused modes. Okay, so now we just have the 4 that we've actually enabled. Then you hit save, okay, and that saves all those modes to your flight controller and allows everything to be working like you want it to. You might have different numbers here, like it might be aux1 or something like that, and that's okay. As long as you have the switch working and it shows here in Betaflight, that's what we want to have happening. Okay, anything else I'm missing here? That's our flight modes, or I guess our modes in general. Black box, flight modes, arm and disarm on switches. Okay. The next thing we're going to do is verify failsafe behavior. So over here in Betaflight, if you have the expert mode enabled, you will see a failsafe tab. And you want to make sure, it should be by default, make sure that the drop is selected as the failsafe. Okay, that's the default one we'll use to start out with. We'll configure the GPS a little bit later, and then we'll use GPS rescue later on. But don't turn that on yet until you configure it, because it won't do what you think it's going to do unless you set it up correctly. So our drop here is set up. That's great. And then this part I can't really show you because I don't have, again, a flight controller with motors attached to it right now. But what we're going to do is we're going to test the failsafe. So what should happen is if we arm our copter and throttle up a little bit on the bench, no props, right, no propellers installed, and then we turn our transmitter off, the motors should just spool down and then shut off by themselves. So that would be simulating this drop. Basically just turn the motors off is the safest thing we can do if we don't have any other way of getting the quad back. We don't want it to continue to fly away. We don't want it to hurt someone if it's hit something. And so that's our fail-safe test. So we'll go over here and zoom out a little bit. Let's pretend my quad has motors, okay? All right, so we're going to take our arm switch we set up earlier. We're going to arm the quad. Oh, I should mention you cannot do this with the USB connected to the computer. It won't let you arm, so that's just something to know. You'll arm the quad. The motors will turn on and start spinning at like an idle speed. Hopefully they turn on like they're supposed to. You can increase the throttle a little bit, and then you're going to basically just turn your transmitter off. Okay, and press enter there. It turns off. This should then spool the motors down and shut them off. Okay, it's a great way to test like a full fail-safe on the bench. All right. Okay. You can also test it via your transmitter by just flipping the fail-safe switch we had set up earlier. So that would be a simulated fail-safe, I guess you could say, whereas turning the transmitter physically off is like a full simulation, like you actually lost connection between the transmitter and receiver because your battery has died in your transmitter or something happened in your receiver or whatever it was. Okay, awesome. Let's go ahead back over here to our assignment. Okay, correctly configure and verify failsafe behavior. The last one here we're going to do is our GPS. And that's a little bit of configuration now. We'll do a little bit more later on in class. But let's go ahead and take a look at that in the Betaflight configuration here. So we want to go over to our configuration tab in our flight control once connected to the computer and everything. We want to make sure our GPS is actually powered up, which should power up on USB for you guys. I have to use a battery for mine, but it should power up on USB for you guys based on where you assigned that. Okay, we're going to look at that real quick. Your GPS should be wired to these ports here in the back. And if we look, we can see it's wired to T6 and R6. So that's an important thing to realize. Again, this is a UART number 6. And then the 4v5 pad means it should power up on USB power alone without having to plug in a battery. Okay. So as you're doing this, make sure you only have the battery plugged in when you absolutely need to. Okay, for motor configuration you need it. For some of the video transmitter testing you'll need it. But otherwise don't have it plugged in. No props on for the entire process. The reason why I won't want the battery plugged in all the time is because the video transmitter will overheat if it's just sitting there on the bench for a long time and it can get damaged. So be aware of that. excessive battery on time on the bench is not good for your video transmitter. But we see here T6 and R6. So let's go back over to the Betaflight, and we'll go to our ports tab, and we'll go to UART6 right here. Okay, and we're going to say peripherals. I'm sorry, not peripherals. Where is it at here? There we go. Sensor input, GPS. Okay, we're going to select GPS there, and we're going to save and reboot. Okay, now mine is not on that number, if that makes sense. This port tab will look different than yours because I'm on the bench flight controller right now. So I apologize for that difference there, but just what I'm working with here. Okay, so if we go over here, I still have my bench flight controller out. All right, I switched the flight controller back over, make this more one-for-one. I stopped the video there in the middle to swap that back. So I wanted it to be like you guys' will look. So on UART6, you will go ahead and select GPS, and you'll save and reboot. Okay, we should be able to go back to the ports tab and see it's still set to GPS. It's saved like it's supposed to. It won't say auto anymore. It will say a baud rate right here, and that's just fine, but we want to make sure GPS is showing there. Okay, and you can see I have my little flight controller here. So, all right, so once you have your GPS set up and connected to Betaflight in the ports tab, then you should have your flight control reboot and everything, and then you'll get a GPS icon up here, which you haven't had before, in red, right? It's not healthy, at least in my case. I'm in a building that doesn't have good GPS reception indoors, but it is showing up there. And then your ports tab, it'll be enabled, okay? And I had to switch back to the flight controller that has a GPS on it, so I apologize for the kind of brief video cuts there. Let's go into our configuration tab now, and we'll make sure that, let's see here, our GPS should be over here. Here we go. GPS. Oh, I guess I'm mistaken. Sorry. I think I'm something else. Our GPS status is turned on, but that's turned on by default. So now we'll go over to the GPS tab. Okay. And this is where we can configure the actual GPS, I guess, function of the flight controller. And so this switch here, GPS, needs to be turned on. You want to set the protocol to uBlocks. And you turn on auto config. Okay. You can also turn on use Galileo. It's just another constellation of satellites. Why not use it? These little question marks will give you more information about these different things if you want. Okay. The set home point once thing. Okay, so the first arm after the battery is used as the home point. Okay. You probably want to set this to be on because the first time you fly will be like probably taken off right in front of you or something like that. Okay. If you don't have this turned on, then every time you arm the aircraft, it will set a new home point. So let's say you take off from in front of you, you fly out in the field, you kind of like crash into an obstacle or something, and you land, and you're going to take off again. So you've already disarmed, and you arm again. Now we'll set the home point as that spot out in the field. So then if you happen to need the home point, like for return to home, it will fly back out to that spot in the field instead of flying back over to you. Okay, so you want to set home point once, yes. Okay. Ground assistance type, you can just do auto detect. If there's ground assistance available for the GPS, then that's great. If not, then that's fine. Okay, you can see right now I don't have any satellites. There's no GPS fix. I'm in like a big brick building, so probably not gonna get a fix in here. But if you're by a window or something, you should start to see some satellite IDs pop up in here, and then you'll start to see some things on a map as well over here. And so that's encouraging. It's working and connecting there. And you'll start to see some stuff over here. Maybe you'll get a 3D fix if you're in a good location. Okay. But the main thing here we're configuring is these settings over here. Save and reboot. Excuse me. I'm going to go back and make sure those settings got saved. So that's good. Excellent. Okay. So the main parts of the GPS configuration here, okay, is to make sure it's enabled in the ports tab, which we did earlier, and then that it's functioning, okay, and it's the flight controller can see it. It's seeing some satellites. Maybe if you need to take it outside or something, that's fine to take it outside for a minute and make sure you get a few satellites, and then that's working great. We're not going to do anything else with it right now. We'll do that in a later assignment where we actually set up return to home and all that good stuff. Okay, so after you've done all this stuff, here and everything's worked out okay, and hopefully haven't run into many issues, okay. To turn this assignment in, you're going to go ahead and do a CLI diff process again, just like you did in the previous assignment. So let's go ahead and go back over here to our Betaflight configurator, CLI, and we're going to go ahead and say diff all, and press enter, and then we have a bunch of stuff that has been saved from our flight controller that we set up. So here we can see my serial ports, my UART set up for my receiver and my video transmitter and my GPS. We have our flight modes and things like that. We have some of our GPS settings and so on and so forth. So this will help me know that you've done what you said you're going to do, basically, and set up everything appropriately. Again, to save that, you go ahead and save it to file, or you can copy it to clipboard and paste it into a file, whatever you want to do. You can save that to file, and then you can save that and upload it to Canvas for your assignment. Okay. That should take care of everything in this assignment. Remember, if you need to bind your transmitter receiver, I have some links in the page to go ahead and do that separately. And yeah, happy flying. Hopefully the test hover goes well.